Good morning, everyone. I will be speaking today about hurricane prediction. It's certainly a large topic, and I have only 15 minutes. So I decided to talk about two storms, Hurricane Sandy. I hope you still remember Hurricane Sandy from last year. And also we'll speak about 1938 storm. Many of you know that tomorrow we will mark the 75th anniversary of the 1938 storm coming to Rhode Island and Connecticut. It actually made landfall on September 21st. In fact, the day before that day was a beautiful sunny day as today. And there was no warning that a hurricane is coming. So I'll try to compare these two storms and would try to convince you and to show you that it couldn't be more different storms, like Sandy and 1938 storm. So let's start with Sandy. This is a path or track of the storm. Actually, the red line shows the center of the storm. And the storm made landfall in New York, New Jersey area on August 29th. And you can see also these two satellite images. Those satellite images are very important and actually very critical for hurricane forecasters. Not only know where the hurricane is at a given time, but also the size of the storm and intensity of the storm can be estimated from those images. So if you look at the image on the right, this is an image of Sandy just a day and a half before the landfall. And you can see how large the storm was. It's actually occupied a space from Florida to New England. The diameter of the storm was about 1,000 miles. It's actually the largest storm on the record. Okay. So let's first remember the impact of the storm. The official death toll in the US, 72, people who directly died during the storm. And the storm affected 24 states, from Florida to Maine and west to Virginia and Michigan. The major or record storm surge along the coastlines in New York, New Jersey, Connecticut, Rhode Island, and Massachusetts. And widespread heavy rains, very actually well inland. And for the first time, the Hurricane Center actually predicted a snowfall in the Appalachian Mountains in West Virginia. And it's estimated about $50 billion of damage. So one way to look at the scope of the impact of Sandy is to look at this map that was produced by FEMA. And you can see actually the large extent of the damage west to Ohio, north to Maine. So it was really a significant, very large impact in the US. So let's look at the storm from a meteorological perspective. This is the map of the maximum wind. And the color actually indicates the storm intensity. Yellow is tropical storm. And red is the hurricane strength wind. And you can see only one location in Long Island that was recorded a hurricane strength wind. So at landfall, it mostly was a tropical storm intensity wind. Now, if you look at the wind gusts, and the wind gusts are those high frequency variability in the wind, of course, we reached the hurricane strength wind gusts in many locations. One thing I really want to point out is that you can appreciate the size of the wind footprint by comparing the wind magnitude at different locations. So if you look at the Rhode Island, so we had a wind gust up to 70 miles per hour, and those gusts were not that different from those experienced in New York and New Jersey. So actually the wind was such with a large extent that it did not decay much from the storm center. And this is one of the unique features of the Sandy, was really a slow decaying wind at the storm periphery. This is our own observations. This is the weather station at the Graduate School of Oceanography at URI. It's a one-day record of the wind speed on October 29th. And so we recorded the wind speed reaching 65 miles per hour at 3 p.m. on October 29th. Of course, the big impact of Sandy was the flooding. And this is the map produced by the NOAA National Hurricane Center showing the essential water elevation above the ground. And you can see the numbers in feet. The highest elevation was observed in New York, New Jersey area, up to 9 feet, in some places even larger. That was certainly a huge flood event. So let's look at the forecast. And I will show you just only one example. This is a forecast produced by the National Hurricane Center on October 26th in the morning. It's 3 days before landfall. So at that time, the storm was near the Bahamas. And you can see this black line is the forecasted track. But really, you need to pay attention to the swath of this white area. And this is where the uncertainties are in the prediction. You need to remember that each forecast, by definition, is wrong. There's always uncertainties. We will never be able to precisely predict where the storm is going to go. And there's many reasons for that. So we always look at the uncertainties in the forecast. So this white line that surrounds the storm, black line, this is where the high probability the storm center may go. Again, but this is only about the center of the storm. The wind extent could be much larger. And of course, you don't look at this line as the area where the most dangerous place is, because the large extent of the wind, you can see that, for example, Massachusetts and Rhode Island was still much away from the storm center. However, we did get a significant wind. So what I wanted to point out in this forecast is this a prediction that storm will make a left turn. So essentially will curve to the west, which is very unusual for hurricanes in the Atlantic. They typically, when they move to the north, they proceed to the northeast. This storm was very unusual. It made this very sharp turn. And the Hurricane Center, 3 days before the landfall, was able to predict that storm will make this large and turn to the left. And the reason for that was the computer models that are currently used for weather forecasting and for hurricane forecasting. And you see what on this figure are different computer models having different forecasts. And there's some odd forecasts you see from some models. It's old models, not very reliable. But the most reliable computer models predicted that storm will make that sharp turn to the left. So it's really a great testimony to the improvements in the numerical weather prediction technology and the computing technology that now allows us several days in advance to predict sometimes very complex hurricane tracks. And I also wanted to show you some experimental new hurricane models that are being developed. These are research models. On the left is the forecast made by several of those models, October 26th. And then on the right is the forecast made on October 27th, just 2 days before landfall. And you can see that all these new computer models converged very nicely into the locations of the potential landfall. And that, of course, gives a great confidence to hurricane forecasters when they see the convergence of different computer models in their predictions. Another example I want to show you, this is a forecast done by the Operational Global Forecast Systems called GFS. It's an official weather forecast system that is used for everyday weather predictions, but also this model is capable of predicting hurricanes as well. And this is a forecast was made on October 27th, 2 days before landfall, and you can see the location and the size of the storm was very well predicted. It's amazingly accurate forecast was done at this particular time. So of course, given the destruction and the impact of Sandy, we couldn't escape to discuss the potential impact of global warming or the climate change on Hurricane Sandy. And this is headlines from different newspapers. And of course, this is a very important topic to discuss, and I wish the media discuss more these topics of climate change, not only during the extreme events. And certainly we cannot relate a particular weather event or particular hurricane with the climate change, but we can look at some signatures of every event that might be related to the climate change. It's certainly a very hot topic in the research, and there's still a great deal of uncertainties about the relationship between the tropical cycle and the climate change, but we can do some speculations and develop some hypotheses of what kind of climate-related factors could have contributed to a hurricane like Hurricane Sandy. And so one factor was that last year we had a record-breaking sea surface temperature in the Atlantic, and that helped to develop the hurricane like Sandy late in the season. So one of the thick signatures of global warming is that we may see extension of the hurricane season. Now, official end of the hurricane season in November 30th, this could have been extended further. Now, another signature is the weakening of this jet stream. Typically, jet stream serves to move the hurricanes away from the coastline, but because the jet stream was quite weak, it allowed Sandy to make the sharp turn to the left. Now, why? Some studies indicate that the climate change might lead to weakening of the jet stream. Another signature is this blocking Arctic weather system was right north of Sandy, and that actually helped to drive the Sandy to the left, to the west. Some studies indicate due to the ice melting in Arctic, we might see a more frequent appearance of those high pressure systems in the Atlantic, which may collide with tropical cyclones, may lead to conditions more favorable for them to make this left turn towards the US. So we might potentially see, if these conditions indeed will take place, that more storms will make landfall in the US. And also, of course, a big concern is accelerated sea level rise in the Northeast. Recent studies indicate that the sea level rise is about 4 times faster in the Northeast compared to the global average. So certainly the contribution of the sea level rise will lead, and the storm surge would lead to a considerably more flooding and more extreme flooding events during the landfalling storms. So let's talk about now 1938 storm. Let's remember that when hurricane made landfall, it's estimated about 600 people died, mostly in Rhode Island. And throughout New York and New England areas, estimated 2 billion trees were knocked down. Just want to remember this number, 2 billion trees that are estimated knocked down by that storm. So this is a path of 1938 storm. And I want to also point out on these 2 locations which I highlighted in red. The red circle in the Bahamas, this is where the storm was on September 20th, a day before landfall in Rhode Island in Connecticut. And another red circle is the location of Rhode Island. It took about 1 day for the 1938 storm to reach Rhode Island from the Bahamas. And the storm accelerated and actually started to move very rapidly to the north, very different from Hurricane Sandy. And here I directly compare the 2 tracks, the Sandy on the left and 1938 to the right, and I highlighted that you see that the region that each storm passed over one day. One day for Hurricane Sandy, Hurricane 38 to reach Rhode Island from the Bahamas, and took 3 days for Sandy to reach New York, New Jersey area from the Bahamas. So very different two storms. One is slow-moving storm like Sandy, and a very fast-moving storm like 1938 storm. Let's look at the September 21st, this day that hurricane made landfall in Rhode Island and Connecticut. At 8:30 a.m. in the morning, the storm was near the Cape Hatteras. At 2:30 p.m., it made landfall in Long Island. And 4 p.m., the storm made landfall in Connecticut and Rhode Island. 5 p.m., it moved to Massachusetts. 6 p.m., it reached Vermont. And 10 p.m., it crossed Quebec. The storm came to Rhode Island with a speed of about 70 miles per hour. It was a very fast-moving storm. And obviously, you can expect a significant inland damage from the winds of such a rapidly moving storm. So this is not a coastal event anymore. This is a significant inland impact you can expect from such a fast-moving storm. So this is actually a computer-generated footprint of 1938 storm. We call it the swath. It shows the maximum wind speed that each location experienced during the passage of the storm. So the red is color. It's about 100, 110 knots, 120 miles per hour. And you can see a significant wind inland. So one fact that is often misunderstood, that the wind damage is proportional roughly to the cube or exponentially increases as a function of wind speed. So, for example, if wind speed increases by 10%, the wind damage increases by about 30%. So there is a huge difference between the wind speed of 70 miles per hour that we experienced during maximum during Sandy and 120, 130 miles per hour. You can expect at least twice or even more damage by the storm like 1938. So this is just estimations done by insurance companies, what kind of damage we could expect from a storm like 1938 in New England. And they expect that most roads will be completely impassable. Most trees will be knocked down. Estimated insurance losses about $40 to $55 billion in New England. They estimate that about 10 million people will be without power during the first day, and 1 million without power 7 days or even more in some locations. And finally, if you would like to know more information about other storms that make landfall in New England, and also how we observed, forecast hurricanes, we developed this educational hurricane website. It's called the hurricanescience.org. This project has been funded by the National Science Foundation, and this web resource became an important resource classroom tools for science teachers, informal educators, and students. And I really encourage you to take a look and visit that website. And I will stop there. Thank you.